Welcome back, everybody. In this video, we will be covering the final part of Lecture 14. The topic is implied volatility in the Black-Scholes option pricing model. Option prices are unique in that the prices reflect the market's assessment of future volatility. That is, if you look at option prices, such as calls and puts, that are being traded, then you can form an inference about what the market expects return volatility to be in the near future. One way that people commonly trade options is they trade in terms of volatility, or relatively in terms of the volatility. For example, if you think volatility is going to be higher in the near future than what the market is assessing, then you should go long options because the options that are being traded are cheap relative to what they should be priced in your opinion. And if you think volatility is going to be lower than what the market is expecting in the near future, then you should short options because they are rich in price. A key feature of this trading process is being able to back out the market's assessment of future volatility from option prices. And the way that you do this is by using the implied volatility algorithm for Black-Scholes. The implied volatility of an option is the volatility that sets the Black-Scholes model price equal to the market price. More succinctly, it's the volatility that is implied by the market price. You invert the market price to tell you what the volatility is that the market is expecting. The way you solve for this is through no simple formula like the Black-Scholes call and put prices. Instead, what you need to do is use an iterative numerical procedure. That is, what you're going to do is you're going to observe prices in the market. So say a call option has a price of C0 market. This is what it's trading at today. You want to understand what the market's assessment of volatility is that's going into this option. All the other inputs to the option, remember, are observable to you: the strike, the risk-free rate, the maturity, and the stock price. And the way you do this is by iteratively guessing and checking volatilities and plugging them into the Black-Scholes price, and then finding the volatility, okay, that is going to give you the Black-Scholes price that is closest to the observed price. That is, you calculate a difference, you calculate a squared difference between what you observe in the market and what is implied by the Black-Scholes model for a given level of volatility. Then you guess and check over volatilities until you find the one that gets the difference between the two as small as possible. This volatility that minimizes the difference between the market price and the price implied by the Black-Scholes model is known as the implied volatility. And so for calls, what you do is you minimize the difference between the market price on the call and the Black-Scholes price. And for puts, you do the same thing. You're just going to use an iterative procedure. Okay? Remember, the whole point here is you want to trade in terms of volatility. You have a view or a belief about volatility. You need to infer what the market is expecting volatility to be from existing option prices. And the way you do this is put everything on an apples to apples scale. You use the Black-Scholes model to invert the market price, tells you what the market's expectation of volatility is, and you can trade on that. Again, you can't do this through a simple formula. It has to be backed out numerically. And the easiest way to go about doing it is just by using Excel. So I've written down a 5-step procedure for you to do this in Excel. It's very straightforward. So suppose you want to find the volatility that's implied by an option price. Say the option price is C sub 0 market. It's given like, say, $5 or something like that. Okay? The way you find what the volatility is, say you're given the K, so you're given K, T, R, and S0 as well. Your first step is you go out, you create a cell in Black-Scholes. You create a cell in Excel, excuse me, that contains this market price of the option. Okay, it's just like a cell. There's a cell C0, and next to it you input $5. Okay. Second step, what you do is you create cells for each of the Black-Scholes inputs. You know what K is, you know what T is, you know what R is, you know what S0 is, so these all get hard-coded in. But you also create a cell for a guess of sigma, and you just select some arbitrary number here. You just plug in anything. Say you put in 1.00, it's not going to matter. Okay, we're going to guess and check over this value of sigma to get the Black-Scholes price to match this market price. Then what you do is you create a final cell that does not hard code, but rather it's a formula cell that calculates the Black-Scholes price, either call or put option price, given the following inputs: the stock, the strike, the risk-free rate, the time to maturity, and the volatility. So you have a cell that's, say, C0 Black-Scholes, okay? And in this cell, what you're going to have is S0 times phi of D1 minus K e to the negative RT, phi of D2. But of course, you're going to plug in your values for D1 and D2. These are all going to be formulas. Same with this is going to be norm dot S dot dist. What this cell is going to give you is it's going to take in all these inputs that you've hard-coded. Okay, volatility is going to be a variable it's going to select eventually, and then calculates out what the Black-Scholes price is. So whenever you change one of those inputs in your Excel spreadsheet, this Black-Scholes price should change as well. Okay, final thing, you create a cell that calculates the square difference between these two prices. Okay, there's one cell that is equal to the difference, and it's equal to something squared, where that something is this model price up here minus this right there. Okay, and you square. And finally, what you're going to do, this is going to give you a difference. Say it will give you a difference of, say, like equals to 2 or something. You then want to use goal seek or solver in Excel to select the volatility that minimizes the square difference in prices. So you use goal seek to set the the cell over here, okay, that's equal to the square difference, equal to 0 by changing the volatility cell. Okay. What this is going to do is it's going to iteratively guess and check over all these volatilities. It's going to find a volatility that sets this difference equal to 0. And what this is going to be is what we're going to take as the market's expectation of volatility based on their assessment of price. It's called implied volatility. Okay, so that wraps up implied volatility. Let's conclude. Lecture 14 was all about the Black-Scholes option pricing model. Black-Scholes model is the continuous time limit of the binomial model, and there's two key assumptions. The first is that volatility is constant and deterministic, and second is that returns are normally distributed under the risk-neutral measure. Black-Scholes gives us pricing formulae for non-dividend paying stocks, or calls and European calls and puts on non-dividend paying stocks. These two formulas are intricately related to one another via put-call parity. And implied volatility, if you want to know the market's assessment of volatility conversely, given an option price, you can use the implied volatility algorithm. A final note, this whole set of slides has been without dividends. Okay, you can easily incorporate dividends in the Black-Scholes model. Dividend yields are most easy to incorporate. I give you the formula for the dividend yield Black-Scholes call price formula below, and the put price is given by the put call parity. All it is a very slight adjustment to two terms, not a big deal, easily incorporated. You can also incorporate discrete dividends as well, as long as they're deterministic. So that's it for this lecture. I'll see you guys in the next video.